In this lesson, we will apply boundary conditions to the FE model that we created in the last follow along video. So the first thing that I'll do is right click and add a new section, which I will label boundary conditions. And if you haven't followed along in the previous lesson and you don't have this file, that's okay. You can download this starter file in the link below this video. So we have this FE model. We have this FE model that we already created, and we're going to apply our boundary conditions, which we have in our geometry section already labeled as our restrained face and also our loaded face. So we'll use these to locate our boundaries for those boundary conditions. I can choose my boundaries conditions from my simulation tab. So we have those options here, as well as in our design analysis tab, we have them separated as restraints and also loads. And I'm going to begin by first picking a restraint. So I'll click on that boundary conditions section and I'll go to my restraints and choose a displacement restraint. And we have to define our boundary. So if you want to review how to create your boundaries, you can go to our Guide to Meshing course, and that lesson is linked below this video, but we'll also briefly review this as well in this video. So what I'm going to do is right-click on this input, and I'm going to use our FE boundary by flood fill. I could also use our FE face boundary, and I'll use that later, but just to show two different options. So I'll click on my FE boundary by flood fill, and we can see it'll take in my mesh. I can select nodes, for instance, for that entity, origin, angle, and direction. But another option that we can do to simplify this process is we can click on our FE mesh that we created before, and then we'll just right-click on the location that we want and select that FE boundary by flood fill. So now we can see I already have that location, I have that entire hole, and I have all of the inputs in place. So that FE mesh we had visualized is in that input. I can change from nodes, edges, or faces. And for this example, I'm going to use nodes, but it doesn't really make a difference for the simulation. We also have our origin. That's going to be where we clicked on our our model, our FE mesh, and then we have our angle. So I'm going to place in this completed FE boundary by flood fill block into our displacement restraint. And once I do that, we have our boundary restrained in the X, Y, and Z and in rotation. And if I turn this on, we can see I have these red cones that are indicating I have a displacement restraint on all of the nodes. So if you can see, I don't see all of the red cones at the bottom, but that's okay. If I turn off that FE model, we can see that every single node in that hole is selected. So what I'm going to do is right-click on that displacement restraint, make it a variable, and I'll label this our fixed restraint. So now I have my first boundary condition, and the second boundary condition that I'll do is going to be our loaded face here. So instead of using that FE boundary by flood fill, this time I will use our FE face boundary. But first I'll go to our design analysis and loads and select a force. So for our force and that boundary, I'll double click and I'll choose our FE face boundary. We already have a CAD face to work with. I don't need to use that CAD face list. So what I can do is just delete that CAD face list, bring in that loaded face. For the mesh, we're going to use that same FE mesh that we have in our model and for our displacement restraint because that overlaps with where our loaded face is. And for entities, I'll also select nodes, and so every node that intersects with that loaded face is going to be selected like so. So now I have that FE face boundary. I'll type in my vector for the force, which will be 0, 0, negative 600 newtons. So that's going down in that Z direction, and we can see that I now have these yellow arrows indicating the location of that force on each of those nodes and the direction, which is down in that Z direction. So now that I have my force defined, I'll right click and make this a variable and label it force. And all of my boundary conditions are completed for this brake pedal. And the next step that we'll do is run our static analysis, which you can watch in the next follow along lesson.